Hello and welcome to the Multi-Tenant AI-as-a-Service for AI Factory screencast. We've built a multi-tenant AI-as-a-Service solution for deploying and scaling large language models and other AI models along the HPC Cloud Edge Computing continuum. This architecture is designed for AI factories, environments where different teams can run their own models independently on shared GPU-native infrastructure. This isolation and control enables true multi-tenancy, allowing organizations to consolidate AI workloads without losing autonomy or performance. We support both Ray and NVIDIA Dynamo for orchestrating distributed models deployment and scalable execution. You can choose between vLLM and Hugging Face for optimized inference, whether you're prioritizing latency or throughput. You can quickly get started with ready-to-use models like Llama, QN, or EuroLLM, all pre-integrated into the solution. The platform is compatible with the OpenAI API and supports quantized models, making it ideal for serving workloads at the edge or under constrained resources. It comes with full support for vGPU, GPU pass-through, and multi-GPU setups, so you can customize resource allocation to each tenant or workload. Whether it's on-prem, in a public cloud, or at the edge, the platform adapts to your infrastructure strategy. Everything is deployable via the OpenNebula public marketplace, so you can easily launch a secure, scalable AI service wherever you need them. Here's a quick overview of what we will be walking through in the demo. A fully functional deployment of EuroLLM using OpenNebula's AI as a service solution. We'll begin by installing the Ray Appliance as a virtual machine using a template we've previously downloaded from the OpenNebula public marketplace. The appliance provides the runtime environment for deploying and scaling GPU-accelerated LLMs. Next, we'll configure the service, selecting the EuroLLM model from our menu and choosing the deployment mode. In this case, we'll use our native integration with Hugging Face. Then we'll deploy service to a GPU-enabled host where Ray Appliance will be instantiated as a virtual machine. Finally, we will connect the VM and launch the chat interface to start interacting with the model fully locally without relying on any external APIs. This demo highlights just how simple and powerful it is to set up an AI as a service environment with OpenNebula. We've also been adding new capabilities to AI as a service stack to better support demanding LLM workloads. First, we've enabled multi-GPU inference using Ray and vLLM, which is essential for large models that need to scale across multiple GPUs. We also support GPU profiles, so each tenant gets just the right amount of GPU power they need. Next, we've introduced quantized model serving, including support for INT4 and INT8 formats. This can boost efficiency by up to 4 times, which is especially valuable for edge deployments or shared environments where resources are limited. And we're extending the platform with deeper AI workflow capabilities. We're adding RAG support, that's retrieval augment generation, allowing models to access external knowledge bases for more accurate and grounded responses. This will be available in the upcoming releases. We're also supporting training workflows through the Ray Appliance, make it easy to fine-tune and pre-train models in the same environment where they are implemented. And finally, we've integrating NVIDIA Dynamo, an open source framework for low latency distributed LLM inference that enables scalable deployment through the dynamic GPU scheduling and optimized memory management. All of this turns OpenNebula into a complete, open, and production-ready platform for running LLMs at the scale on your own infrastructure. Now that we've seen the architecture capabilities, let's jump into this demo where we will deploy and interact with a real LLM using OpenNebula AI as a service stack. After logging into the OpenNebula dashboard, we head straight to top and click plus button to instantiate a new appliance. From the template list, we're searching for Ray Appliance, specifically the version configured with 1 vGPU, which is what we'll use to run EuroLLM locally. We name our service EuroLLM. For the hardware spec, We'll go with 20 gigs of memory and 10 virtual CPUs, enough resources to handle a smooth LLM experience. Once that's set, we click Next to continue. Now we land on the LLM configuration screen. Here we can tweak a few important settings. There are two toggles at the top that control how the LLM is deployed. If none are enabled, the model defaults to Hugging Face. If we enable just one, the system switches to vLLM, which is optimized for speed and GPU inference. If both toggles are enabled, we'll get vLLM running with an OpenAI-compatible API interface, meaning we can interact with it using the same structure as we would with OpenAI models. We also have a temperature slider. This controls how creative or random the model gets. A higher value adds more variation, but can also introduce more hallucinations. Then we select the actual model we want, in this case EuroLLM, and define an initial prompt to load the assistant with the context or personality from the start. In the final screen under placement, we choose the specific GPU host where we want the LLM to be deployed. Once selected, we click Finish and the deployment process begins. Now the system starts bootstrapping our Ray-based LLM appliance. It'll take a bit of time to set up, and once it reaches the running state, we can verify it from the command line by typing one VM list. Let's go ahead and SSH into the virtual machine that's hosting our EuroLLM. Once inside, we navigate to the directory where all the Ray and LLM related files are located. We run Ray status. This confirms that Ray is active and that we have one running node. To check GPU availability and usage, we type NVIDIA SM. And here we can see the exact GPU specs and current load, confirming our vGPU is in action. Time to start the chatbot. Once we open the web app, we're welcomed with a clean chat UI. Let's try out. We type describe what the AI is, and we get a quick and coherent response. Now let's ask, list the 10 biggest cities in the world. The model responds instantly. This screencast is produced in the scope of ONEnextGen project. Thank you for watching and see you in the next screencast.